So I've got a few minutes here before tutoring starts. Maybe I can get through the box and whiskers plot on the first example here. Let's determine the mean, standard deviation, median, mode, and a 5-number summary for the following data sets. Then draw a box and whisker sets. Now we're going to do pretty much all of this in a TID4. We're going to click Stat. It'd be nice if that text wasn't white and you could read it. We're going to click Stat. We're going to click Edit. I'm going to put everything into list 1. When you were in middle school, they should have taught you how to do everything but standard deviation by hand. They should have. I don't know if they did or not. They probably did, you just don't remember it. Then you also run into situations, and this happens often, I'm guilty of it myself, is there's just so much to do and your kids just can't seem to do any of it, so you go super slow. 5, 8, 5, 9, 6. I'm just putting the stuff in list 1 like I said. Mainly I'm just talking to myself. It means I'm either intelligent or crazy. Possibly both. Alright, checking for typos. Alright, from here what I'm going to do is I'm going to click Stat, Calc, 1 variable statistics. There is no frequency list, there's just something in list 1. So be careful about a frequency list. You only use a frequency list if you have 2 lists. You only have 1 list. So calculate. And there is everything. So my mean x bar is 8. My standard deviation, which is sigma of x right there, is 2.97. If I'll scroll a little bit, I'll get some things there. The median happens to be 8. It's interesting, they match. Doesn't happen too often. I don't think it'll tell you mode. It won't. So mode is the number that occurs most often. I see 2 8s. I see 2 9s. You see anything else? 2 5s. This thing is multimodal. Interesting one. Your modes will be a set that includes 5. Sorry, I saw 3, I think. No. I saw 5. I saw 8 twice. And I saw 9 twice. I tend to miss these for some reason. But it's multimodal. It doesn't have a single mode. It's multimodal. The 5-number summary is the max and the min. The minimum is going to be 3, and the max looks like it's 14. The calculator will give you the first quartile and everything like that, and I'm just checking to make sure I didn't miss a number. First quartile, if we're doing it by hand, would be one thing, but we don't have to. This says the first quartile is 5.5. Median is 8. I already know, I'm looking, I already had that down. Third quartile is 9.5. And the interquartile range is 9.5 minus 5.5, which is 4. Now we're going to get to do a box and whiskers plot. Maybe you remember those, maybe you don't. I have no idea what you remember. Now, Art, I'm going to switch over to pen real quick because it's quicker, and I don't have all day. I'm also not plugged in. So my low value is 3, my high value is 14. My median's at 8. And when I draw this box and whiskers plot, it needs to go from 5.5 to 9.5. Anyways, 9.5 is pretty close to 8. 5.5 is a little farther away. And if I remember right, that's a box and whiskers plot. It's been a while since I've done it. But it shows you where you are, and it shows you kind of the range of normal. That's kind of what this means. Like this little range right here, this interquartile range, this is the 25th through 75th percentile. And it's kind of a definition of normal. Well, that's really what it is. It's a definition of normal. So, there you go. I got through the box and whisker plots. Maybe I can get through another one. Alright, what was the instruction set on this one? I think you were supposed to describe. Let's just pull that up here. You're supposed to do something. Describe the shape of the data summarized in the histogram. Alright, makes sense. It looks like that. Now notice the tail runs left. This is a, sorry, not left. Ooh, Milbrath. The tail runs right. This is right skewed data. What does that mean? On a right skewed, I think it generally means that the mean is greater than the median. That's what it usually means. But anyways, it's a right skewed data. That's all you're supposed to do. Determine if each situation is likely to be uniformly distributed, which is a flat line, normally distributed, skewed left or skewed right. For each example, draw the curve with labeled axes that help you arrive at your conclusion. So I highlighted two of these, 11 and 13. And the first one is the age at which people die in the United States. Now, it occurs to me that more old people die than young people. All right, so this is kind of a justification of what I'm about to do. And the real thing is how you want to do your axes. Do you want your axes to be the age, or do you want it to be, we want our x-axis to be the age, and we want to be the y-axis to be kind of like the death rate. And you would expect that when people are young, there wouldn't be a lot of death. Might peak a little bit in your teenage years, get a little higher at 21, but then it's kind of stay there for a while until people get around their 40s and 50s, and then it's just going to start going up. Should look something like that. The tail runs left. So this is left skewed. All right, the height of all adult families in Tennessee, whatever a family is, what is a family? The height of all adult families in Tennessee. I would expect that to be normal. That's kind of the thing. Height is usually normal. It's going to be a pretty good distribution. You're going to have some short females and you're going to have some tall females, but if we just did a height range from like 5 foot to maybe 6 foot, this would be your height. This would be the frequency, the number of whatever a family is, family. We would expect to see, about the same number of 5-footers as 6-footers, and it would kind of be somewhat proportional as things go on. And we get a nice, smooth, normal bell curve. So a normal bell curve. And that was my bell for tutoring. So I am off to tutoring. Got a little done. I'll do the rest in the morning.